Hello, summer learners. Welcome to the San Mateo County Library's STEAM Camp. My name is Alice, and I'm a librarian for the Portola Valley and the Woodside Libraries, and I'm so happy that you are here today with me. Before we get going with our activity, I wanted to make sure that you know that you can pick up books at the library now. We're offering curbside pickup for library books by appointment 5 days a week, Tuesday through Saturday. And we are also offering free books that you can come and get with no appointment as part of our summer learning challenge. So if you haven't gotten a chance yet, you can go to any of our 12 branches and pick those up. You can get more information about our hours and how to make an appointment to pick up your library books at smcl.org/curbside. So hopefully we'll see some of you outside the library soon. Now, I wanted to just go ahead and dive straight into our activity today because it's one of my absolute favorite things to do in STEAM. So if you've watched my videos before, you know that one of my absolute favorite parts of STEAM is that M, which stands for, drumroll, math. I love math so much, and I especially love the part of math called topology. Now, if you joined me a few weeks ago, you might remember making Mobius strips. You can kind of see one on the wall up there. And those are topology. But does anyone remember what exactly topology is? Yeah, it's a little bit like geometry, but not exactly. We're looking at shapes and things to do with like characteristics or things we can notice about shapes, but we're not looking at the same kinds of things as in geometry. In geometry, you might look at how big an angle is or how long a side of a shape is. But in topology, we care about different things. We care about things like, in our Mobius strips, how many twists we put in it and how that made a difference in how many sides there were when we drew a line. Today, we're going to look at how many holes there are in different things and whether we can take one shape and turn it into another one without changing how many holes there are in it. And when you do that, you say that something is topologically equivalent, and we are going to use some Play-Doh to do that. Now, if you don't have any Play-Doh, that's okay, because I know a lot of people are enjoying baking right now, and you can use something like cookie dough or bread dough. I just have Play-Doh today, so no cookies for me. But baking is a great time to do some math together. So go ahead and grab whatever kind of squishy dough you have. And we're going to start out by seeing what we can do with a shape that has no holes. But there are a few rules we have to follow. We have to make sure we don't add or take away any holes. Now, it's easy not to take away any holes from zero, right? Let's take a look at this ball and just make sure. And in math, we call a ball a sphere. So here we have a sphere. And do we see any holes in our sphere? It looks pretty solid. No place you could poke your finger through. But we want to make sure that when we're squishing it around, we don't put a hole through it with our finger, because that'll change that important thing about that shape, about how many holes it has. Or that we don't, say, put two bits together to make a hole. So we want to make sure that anything we do doesn't add or take away holes. And another important thing we need to make sure that we're making two shapes that are topologically equivalent is we can't pull off a piece of Play-Doh and stick it over on this side, because that could change something really important about our shape. So the way we have to manipulate our Play-Doh is just to squish it around and see what happens when we squish it but being careful not to add holes. So let's go back to our ball. All right, do you have your ball? Now let's think about what kinds of shapes we could squish this into. I'm curious what happens if I just, whoa. Kind of looks like I have made a pancake. And I did that. Did I break any of our rules? I didn't put any holes in it. Still has no holes, and I didn't break anything off or put it back on. So in topology, pancake is the same as a sphere. I'm going to go ahead, roll it back up into this ball or sphere. And I'm going to try and make one more shape. I wonder if I can turn this into like a long, thin noodle or snake. So let's see if I can roll it. Roll out that Play-Doh. Do you think I'll be able to turn it into a snake and still have it be topologically equivalent without any added holes in it? Let's find out. Here's my snake. Do you see any holes in this guy? No, it looks like it's pretty much the same. No holes. Didn't break any pieces off to add them back on. So this snake and that pancake and that sphere or ball, they are all considered to be the same shape in topology. It's kind of strange, isn't it? Kind of mind-blowing that you could say they are all the same thing. So I'm going to set aside my snake for a second, and I want to look at another shape. And this is an important shape in topology. It comes up a lot. So let's take a look at this. This is actually a piece of a baby toy that we sometimes put out after story time when we can have story times at the library. But today, I thought it would be a really great example of this shape in math. So let's take a look and see what we notice. Go ahead and turn to, if you're watching with someone, turn to them and tell them what you see. I see that it is round, kind of the same all the way around. I also notice it has a hole in the middle. So this is different from this, because this has a hole and this doesn't. And do you have a name for this shape? There are a few different things we could call it. You might call it a donut or a ring or a bracelet. In math, we call this shape, this donut shape, a torus. I tried to draw a picture of it up on the board here. It was, I'm okay with how it came out. I also wrote how you spell torus up above it. So this is a torus, and I want to compare it to another thing that I found in my house, which is this. Do you know what this is? Yeah, it's a coffee cup or a mug. And I want to think about whether these are the same or different, and what things are the same and different about them. So go ahead and turn to someone you're watching with, or write down what you notice about this as compared to this. Go ahead and rotate it a little bit. I think we noticed that this was kind of the same all the way around. This, if I turn it around, this side is a lot bigger than this thin little handle, and it has this dip in the middle. I don't think this is a hole because I can't put my hand all the way through. It gets stuck inside. Whereas the handle looks like it is a hole because I can put my hand through it. So I think these might be the same in topology. I think they might both have one hole, but I think we could use our Play-Doh to experiment and see if that is actually true. So I'm going to go ahead and grab my Play-Doh again, and I want to think about how to turn this into this. Does anyone have ideas about how we could do that? Maybe if I just take the ends and loop them together. That looks pretty donut-like or torus-like. And now I want to think about how this can turn into this. So we noticed that the handle is kind of thin, so I probably want to try to make the handle on this kind of thin. And then there's the dip in the middle, so I need to figure out how to do that. I think I'll start by making the thin handle. I'm going to squish this up real small, and then sort of twist this. Oh, and let's make sure we remember our rules. What's rule number 1? Right, we can't add or take away any holes in our while we're doing this. And what's rule number 2? Don't break off and move any pieces around. All right, so let's see, I have my handle. And then I'm gonna squish it up. Let's see. Oh, I accidentally broke my handle. I'm gonna go ahead and start over just to make sure, because you know, it's always better to make sure that you're doing your process right and not making any mistakes. So I have my torus again. I'm gonna maybe try to make my handle a little less skinny. And then still squish. I think I'll keep my finger in the handle so I still have that hole. And let's see if I can, without breaking off any pieces or making any extra holes, let's see if I can make the dip in that cup. Well, it's not the prettiest cup ever, but I think it has the important parts. It has the handle that I can put my finger through, and there's a dip that I can put my finger in, but it doesn't go all the way through. So it looks like this and this might be the same. They both have one hole, and I was able to turn my Play-Doh from one to the other by following our rules. So I want to challenge you to take a look around your house and see if you can find other things that might have the same number of holes, and maybe experiment with your Play-Doh and see if you can tell if they're the same. It might surprise you what things have the same number of holes and what things have different numbers. I thought one interesting thing was I found this teapot in my house, and in some ways it's pretty similar to a coffee cup. They both have a handle, they both have a space inside of them for liquid to go in, but the teapot has the spout, and I thought it might be really interesting to see maybe that changes how many holes are in it. So I want to challenge you to see if you can take the coffee cup that you just made, and yours might be a prettier coffee cup than mine. See if you can turn it while still following those rules. Let's say them one more time. Don't add or take away any holes, and don't break off and move any pieces of the Play-Doh. So see if you can turn this into a teapot without breaking those rules, or if you would have to break rules and add or take away holes to make a teapot out of a coffee cup. That will tell you whether they are the same in topology. All right, well, thank you so much for joining me today. I had so much fun. I love topology so much. And I hope also that you have signed up for our Summer Learning Challenge. You can find out more about it by going to summerlearners.org. Basically what it is you get to do lots of reading and do fun activities and tell us all about them for a chance to win a $1,000 college scholarship and a bunch of other really cool prizes. And I hope you join us again tomorrow for another activity from our summer STEAM camp.